asked this in the first batch, they said they don't know this. But then they made the answer, and for a hollow cylinder. If you have a hollow cylinder and a solid cylinder, what is the moment of inertia of this? Is there anybody to raise their hands and tell? Because after I writing the answer, तुम लोग बोले अरे सर ये तो कितना easy था. Come on, anybody to tell me? Yeah.
This plus this plus the formula. mr square by 2 plus mr square by 2.
For which one? This one? It's only mr square by 2. अरे मैं क्या बोल रहा हूँ? If I just slice it off, ऐसा तो क्या? Right? काकड़ी है काकड़ी. Right? काकड़ी को हम लोग ऐसा स्लाइस करते. वो एक स्लाइस कैसा दिखता है? डिस्क. वो सब स्लाइस को जोड़ दिया तो क्या बन गया? काकड़ी. अरे मास तो अलग हो गया. अरे काकड़ी होगा ना जॉइन किया तो वापस. Right? So if I just take all these things together, what will it be? Tell me. Each one is a disk. So the moment of inertia is also for what? Tell me, disk. It's a pile of what? Tell me, disks stacked upon each other over there. Sure about that? So is there anybody to raise their hands and tell me what is the moment of inertia of a hollow cylinder? Stand up and say, yeah. Very good. How did she say mr square? All of you tell me. Pile of what? Tell me, right? Rakesh will later do जो तुमने बोला था ना वो. What she said that also is, that is if you turn it like this. So that is a rod and a what? Come on, disk. That we'll do later over here. But as of now, just remember this over here. What is a disk over here? Tell me, a hollow cylinder. A stack of what? Come on, rings. And what is a disk over here? Tell me, a stack of what? Tell me, disks. Are you getting it over here? Right? So we have done certain formulas over here. Solid sphere and hollow sphere bhi kiya tum loge. Right? If whenever the sphere is not mentioned, remember it is a what sphere? Come on, solid. If they tell you in the exam, they don't tell you what sphere it is. You always have to take a what? Tell me, solid. अच्छा इसका moment of inertia क्या था बोलो मुझे? 2/5 mr square. और इसका क्या था बोलो? अच्छा कौन ज्यादा कौन कम? ये तो अभी सिंपल है, ये आना रहना चाहिए तुम लोग. डिनोमिनेटर बढ़ेगा मतलब नंबर कम हो गया गर्ल्स. थोड़ा देखो इधर. हाँ ये इंपॉर्टेंट है. तो कौन बड़ा कौन ज्यादा कौन कम? 2/3 कम है एंड ज्यादा है एंड 2/5 sure. Then you are trying to tell me a solid sphere has a moment of inertia smaller than a hollow sphere. Reason? बोल are distributed also what? Tell me near. That means moment of inertia, students, does not only depend on mass. What does it also depend on? Distribution of mass. What does it depend on? Tell me are you all sure about that? Moment of inertia depends on two things. What about one? Mass and two. So why is a ring more than a disk? In a ring, where are the particles? Come on the perimeter circumference, and the disk are there inside also here, right? So imagine करो ये एक disk है, right? और ये disk पे एक person खड़ा है, right? अब ये person ने क्या किया ना, उसका हाथ उसके पॉकेट में डाल के खड़ा है, right? आपने क्या किया? आपने वो disk को आके turn किया, right? अच्छा आप ऐसा तू करती है ना, मतलब हाँ तो ऐसा तू किसको देखेगी असली, राइट? अच्छा अब क्या किया आपने? इसने जैसा टर्न करते करते गया, देख जरा इधर, देखिएगा ना तो तेरे को खड़ा करेगा ना ऐसा. मेरे पास चेयर है जिस टर्न हो सकता है, राइट? इसने क्या किया मालूम है? इसने ना हाथ स्ट्रेच किया. अच्छा हाथ स्ट्रेच किया तो क्या होगा? मास बढ़ेगा ना उसका, हवा पकड़ेगा हाथ में. हाँ बोलती है क्या होगा? No, that is not the question only, but क्या होगा? Just you were saying something. Moment of inertia क्या होगा? Increase. Very good. She said the moment of inertia will increase. Why? Distribution is away. I also moment of inertia doesn't only depend on mass. It also depends on what? Come on. Now he said something else over here. He said that he will slow. Now that we will do it eventually. I have not taught you that. I'll teach you that eventually, right? So that we'll do later over here in the next lecture. But as of now, just remember, moment of inertia depends on two factors. What and what? Mass and. So to define the distribution of mass, we define a new term, and that term is called as the radius of gyration. Okay, radius of what? Gyration या gyration जो भी बोलो लिखने का उसको ऐसा. It is denoted by a letter K. What does K try to specify is one. Distribution distribution of mass. I tell you how it means. So imagine you have a body. Okay, shape is not important, right? But the mass of this body is 2 kg. सोचना है आपको, right? And nobody answers out of turn. Okay, Samaira, तू क्या लिख रही है? सोचना है. हाँ, good. कुछ लिखो मत. Pay attention, right? And I am turning this about this axis. As I turn it about this axis, I figure out the moment of inertia. And the moment of inertia is calculated as 50 kg meter square. क्या moment of inertia बॉडी का? About this axis. अच्छा, axis change किया तो moment of inertia same होगा कि अलग होगा? अलग होगा. Sure about that होगा? Now what I do is मैं यही axis लेता वापस. So the same axis, right? तो ये axis और ये axis same है कि अलग अलग है? Same. And what I do is ना ये पूरा चीज को I squeeze it at a point. क्या क्या मैंने बोला? Squeeze. For example, this is there ना over here, right? This is like a big body, right? उसको squeeze किया ऐसा. समझा किया ना तुम लोगों ने पेपर में ऐसा हुआ. But I'm not that strong. The person who's doing this is so strong. इसको squeeze करके एक point पे लेके आए, right? वो point का mass क्या होगा? कितना है? ये तो 2 kg है, तो ये कितना आएगा? 2 kgs. Are you getting it? So you squeeze it at a what in your point, and you keep this point at a distance of 2 meters from the axis. What is the mass kept over here? 2 kgs. And what distance are you keeping it from till here? 2 meters. Okay. What is the moment of inertia of a point? तूने लिखा ना 5 बार? लिखा नहीं? कितना बार लिखा? कितना बार लिखा? आपने लिखा कितना बार अभी तक? एक बार इस बार लिखा? अच्छा ठीक है चल. पर फिर भी तू बोल. What is the moment of inertia of a point mass? खड़े रहे. ये मास है m, ये r है डिस्टेंस. What is the moment of inertia of this point mass? बोलो. वेरी गुड. देख आ गया तेरे को. बैठ जा. चलो m का वैल्यू स्टूडेंट्स 2, r का वैल्यू 2. अरे r का वैल्यू 2 है. 2 स्क्वायर है. चलो तो वो जाके होगा 4 into 2. तो इसका आंसर कितना है बोलो? 8 kg मीटर स्क्वायर. इज दिस नंबर सेम एज दिस? गलत हो गया. सुनो, you cannot answer out of turn. उठाने का हाथ in case you know. So I'm not happy with this. Reason I didn't get the same number. So what I do now is I squeeze the mass and I keep it at a distance of 3 meters from the same axis. Okay, look here, quietly, don't speak. That is 2 into, he said the formula 2, r square. R कितना बोले? 3. So 3 square. 9 into 2. 18 kg meter square. Again I see. अरे शी गलत हो गया. अरे मैं बोला डोंट आंसर आउट ऑफ टर्न. चलो क्या मन में आया तेरे? 5. So इनके मन में आया 5. Okay, look here. So she is taking this m 2 kg at a distance of what? Come on, 5 meter. Let's find out that moment of inertia. बोलो क्या आएगा? 2 into बोलो 5 square. 5 square 50 कौन बोला रे? 25 into 2 50. Okay, now this is important, right? Because it's in red. No, why is it important? Are you all getting it, everybody? This distance is called as the radius of gyration. Are you all getting it, everybody? What is radius of gyration? If I ask you, what would you answer? Chalo, yeah, bolo, in your own words. It is क्या है? Unit क्या है? Meters. So it cannot be moment of inertia. It is what? Distance. Very good. अच्छा ये लाइन का नाम क्या है? Very good. Axis of rotation. अच्छा ये point क्या है? Point where the whole mass is really concentrated or assumed to be concentrated. Can you take a disc and squeeze it like that? No. So we are what? We are assuming it to be concentrated. When I said squeeze means what? Come on. Assuming it to be concentrated. Come on. Anybody to think and tell me what is radius of gyration? Stand up and say.
The distance from the axis of rotation to a point where the mass is assumed to be at.
Assumed to be concentrated. So that
the moment of inertia is equal to the original.
Very good. Perfectly said. What is radius of gyration? It is that distance from the what? Come on. Axis of rotation, where if the mass is assumed to be concentrated, produces the same moment of inertia as that of the body about the given axis. Are you all getting it over here? Imagine now you're turning it from some other axis and you get the same body over here. You get the moment of inertia about this axis as 18 kg meter square. Please tell me what would the radius of gyration be? 3. Are you all getting it? 3 कैसा हो गया? बिकॉज विथ 3 से वो सेम आएगा. तुम लोगों को समझा क्या होगा? व्हाट इज रेडियस ऑफ गायरेशन? अच्छा, ये बॉडी को ऐसा घुमाओ या ये बॉडी को ऐसा घुमाओ, इज द मास द सेम? फिर क्या अलग हो गया? रेडियस ऑफ गायरेशन मतलब क्या पता? मोमेंट ऑफ इनर्शिया दो चीज पे डिपेंड होता है. बोलो व्हाट एंड व्हाट? डिस्ट्रीब्यूशन ऑफ मास. तो रेडियस ऑफ गायरेशन स्पेसिफाइज व्हाट? Distribution of mass. Are you getting that term? Which specifies distribution of mass is called as what? Come on, radius of gyration. What is radius of gyration? Tell me over here. It is the distance from the of rotation where if the mass is assumed to be concentrated produces same moment of inertia as that of the body. You have to say it. Everybody is saying. बोल क्या बोलेगा? Stand up and say, हाँ.
Distance from the axis of rotation to the point at which the mass is assumed to be concentrated, where the moment of inertia is equal to the origin.
Very good. Original moment of inertia about the what? Tell me here. Same axis. So when you say over here, what is the meaning over here for this? It tells you about what? Come on, fast. Distribution of mass. अब तुमने मुझे एक रॉड दिया और तुमने बोला सर इसका सेंट्रल एक्सिस पे मोमेंट ऑफ इनर्शिया क्या था? तुमने बोला था मुझे फास्ट ml square by r नहीं आएगा ना, लेंथ ml square by I equate this with mk square. I equate it टोटल में आया mk, बिकॉज ये तो mk square ही आएगा m into k square. ये चीज को क्या बोला मैंने? k. तो I can write I3 as 2 is what? m. 5 is what? Tell me what? k. So that's mk square. I equate the two. अच्छा mm क्या आएगा बोलो? Cancel. तो स्टूडेंट what is k square equal to? L square by 12. But I want k. What is k equal to? L by root 12. You know, can I write 12 as 4 into 3? जल्दी बोलो. What is 2 का 4 का root? So what is k equal to? Come on. L by. This is radius of gyration. ये समझा क्या तुम लोग? अब तुम बोलते सर मुझे ना रॉड को एंड से घुमाना है. मैं बोला ठीक है. तो मैं करेगा ml square by 3 को इक्वेट mk square के साथ. नहीं समझा? mm वापस क्या आएगा बोलो? कैंसिल. मेरा काम क्या है? ये m को निकाल देने का. तो जो बचेगा कौन है मेरा बोलो? डिस्ट्रीब्यूशन ऑफ मास. तो व्हाट इज k इक्वल टू? कम ऑन फास्ट. L by a. Is this not more than this? Yes or no? That term more is called as the what? Come on. Distribution of mass. Suppose you give me a ring. You give me a what? Ring. Okay. Ring का moment of inertia. All of you together. बोलो क्या आएगा? mr square equal to what? Come on. mk square. What is k equal to? Are you all getting it everybody? Suppose you give me a disk. Come on, tell me. Disk का क्या आएगा? Fast. mr square by 2. What will you equal to? Come on. mk square. K is equal to? So what does this term tell you about? Fast. Distribution of mass. Basic idea क्या है? m को क्या करने का बोलो? उड़ा देने का. Right? So you will get the answers. Is this clearly understood over here? What does radius of gyration tell you? Distribute. Because moment of inertia depends on two factors. Bolo, what and what? So when the person was standing like this and he stretched his hand out, what changed? That means what changed? Of gyration. What tell me over here? Change. I also when he stretches out his hand क्या होता है बोलो? कौन सा टर्म बढ़ जाता है? Increased what? Come on. Radius of gyration. When you fold your hand, what happens? Tell me over here. Decrease the radius of. So you can change the turning. Right? By changing what? Tell me over here. The distribution of mass. That is the reason why. Have you all seen Olympic divers and all? Right? Olympic people over here. Olympic देखा तुमने Olympics? So there's a diving in this way competition. So there is water, right? Right? And a person comes on a board and he dives. He or she dives over here. बराबर? Now as the person dives, ये तो हम लोग भी कह रहे जंप मारो. और भगा देंगे उधर से. Why are they special? Tell me. Are these guys? Are these athletes special? Have you seen a diving competition? What they can do, we can never think also of doing. Unless some of you is there into diving. Does anybody do diving here? No. So we can't think. What do they do? Come on. They create no splash. That was, as I told you, even we can jump. We jump straight, we also don't create splash. Then why is it different? They turn. Their turning depends on how they distribute K. समझा क्या? Right? So when this person dives, क्या करता मालूम है? वो जो करता है, he or she squeezes the body in. देखा क्या आपने? The whole body is what tell me curled. They try to what tell me get the body close to the axis. Close to the axis मतलब क्या होगा बोलो यार? Gyration decreases. मतलब उसका turning effect क्या होगा या ज्यादा होगा. come. वो जो भी है and they come. The moment they come near the water, they stretch the bodies out. मतलब K क्या होगा भैया? बढ़ेगा. ये टर्म में K क्या होता है बोला? कम होता है. Now it happens in such a short instant, right? Where they are exactly able to maneuver that. That's why they get those points. समझ में आएगा? All that changing here is what? Come on. Of, so even they know radius of gyration. Today even we know radius of gyration. Clear? What is radius of gyration? Come on. It is first of all a distance. Remember, it's not moment of inertia. It's a what? Come on. Distance. What does the distance specify? Distribution of mass. Come on. So you tell me the definition. I will write it down. Come on. What is radius of gyration? Yeah, अच्छे से बोलेगा मैं अच्छे से लिखता हूँ. बोलो क्या? It is the distance from the बोलो क्या आएगा? Axis of rotation where distance from the axis of rotation where if the mass is assumed to be concentrated produces the same what? Come on. Same moment of inertia as that of the original body about the same axis. Are you all getting it over here? Right? This term is what telling you your radius of gyration. What is the unit of radius of gyration? Meters. Why kg ना? Meters. Letter is K. Unit क्या आएगा भैया? Meters. How do you write it down? पहला तुमको ये लिखना पड़ेगा. Moment of inertia depends on two things. What and what? Mass and distribution of mass. अच्छा, first of all सबको ये लिखने का. ये कब यूज करने का? Point mass. ये कब यूज करेगा? Collection of particles. ये कब यूज करेगा? Infinitesimal element. ये कब यूज करेगा? Continuous body distributions. बोलो क्या बोलेगा उसमें? Body distributions. And उसके बाद ये लिखने का तुम लोग 1. So this is, I'll tell you, this is A or 1. This is B or 2. This is C or 3. Okay? Come on, all of you. Do it. Did you understand this? उधर देख के recording अच्छा चल रहा है? Thank you. No, don't ask. No. Please don't ask. अरे don't ask. चलो एक मिनट चलो, all of you start writing. I will answer all your doubts. Don't worry like this. तुम लोग ऐसा हाथ उठाओ ऐसा लगता है कि मैं भाग जाता डाउट के पहले. हाँ चलो क्वाइट. Did everybody understand? कुछ भी इधर एक्स्ट्रा नहीं है. प्रॉपरली लिखो over here. Okay, come on. To a point. If the distance from the axis of rotation to a point where if the mass is assumed. Okay, chalo. No. I'll send you. You are doing my job ना. Pause करो उसको भी. Pause मतलब इधर से हाँ. ये लगे. Yes. ये वाला my director जैसा हाँ. इसको तो आता भी है बहुत कुछ. या. चलो do it fast. हो गया? चलो next thing everybody write down angular momentum. Everybody in your books write down. ये हो गया? जल्दी लिखो. You finish writing. तू मुझको बुक दिखा. चलो. Now, so the next thing we'll do is called angular momentum. Now, when I say angular momentum, you have to think about the analogous term in linear motion. Linear momentum. Very good. Okay. So, is there anybody who can remember the formula for linear momentum? NH by 4 pi is Bohr's postulate. Angular momentum. ये कुछ ज़्यादा ही chemistry पढ़ती है. Anyways, it is not chemistry. It is physics only. MB. I'll linear momentum is what? Tell me, mv. So Shanam, what is angular momentum ka formula? Very good, Shanam. It's I into omega. Right? So mass is replaced by what? Come on, I, and V is replaced by what? Come on, omega. That's pretty simple, isn't it? Right? Now this is for rigid bodies. Rigid body मतलब continuous bodies. जब वो इंटीग्रेशन वाला था ना, लिखा था फोर्थ वाला, वैसा था वो, right? So rigid body. How is it for point mass? उसके लिए you have to stop writing, please. उसके लिए you have to remember the relation between L and P, and the formula is, look here, L is equal to, L is a vector, R cross P, not P cross R. It is given as what to me here? R cross P, where R is the position vector, P stands for what? Come on, linear momentum. Okay, and this is because of the angular motion, rotation motion. Remember, all rotation motion vectors are axial vectors. So they are perpendicular to the plane of the motion over there. Are you all getting it, everybody? Remember that always. So rules are given by which rule? Come on. राइट हैंड थंब रूल. यू रिमेंबर दैट होया, राइट? आर क्रॉस पी हो गया. अब आपका पी जो है वो क्या है बोलो? एम बी. तो उसको इधर डाला. सो ये एक फॉर्मूला है, राइट? तो ये फॉर्मूला कैसा मिलेगा हम लोग को? एल इज इक्वल टू आर क्रॉस एम इज अ स्केलर इनटू वी. आई कैन टेक द स्केलर आउटसाइड, सो दैट कैन आल्सो बी रिटन एज व्हाट? कम ऑन, आर क्रॉस वी. ये दूसरा फॉर्मूला है. अगर मैं मैग्नीट्यूड लिखूं इसका, राइट? व्हाट इज आर क्रॉस वी का मैग्नीट्यूड? RV sin theta, so that we can write as MVR sin theta. So what is angular momentum? Actual formula tell me here, MVR sin theta. Okay, if this is R and this is P, the motion, then R cross P is like this, clockwise or anti-clockwise? घड़ी देखो मंगता तो clockwise, पीछे है घड़ी. Clockwise मतलब क्या आएगा बोलो? Negative, right? And if it was R cross R was here and P was here, then how is it? Come on, anti-clockwise, which will be what? Come on, positive. So we are again going to the torque wala part over here. So it is either this is inwards and this is what in here outwards. That's what the arc cross piece. Is this clear to everybody here? Now I told you. So when to use this formulas? This formula should be used for a point mass. And when to use I omega? Come on, for a rigid. What is a rigid body? कंटिन्यूस डिस्ट्रीब्यूशन ऑफ पॉइंट मासेस. सब पॉइंट मास तो साथ में मिला दिया कंटिन्यूसली, तो क्या बनेगा बोला? रिजिड बॉडी. तो आपको ये कब यूज करने का बोला? पॉइंट मास. एंड ये कब यूज करने का होगा? राइट. अच्छा, जब मैं ये बोलता हूं तो बहुत सारे बच्चे बोलते हैं सर पॉइंट मास अगर स्ट्रेट लाइन में जा रहा है तो इसका तो एंगुलर मोशन है कि नहीं है? एक मिनट समय आएगा. सी यू आर राइटिंग वेरी नीटली, वेरी गुड, बट दैट्स नॉट व्हाई यू आर कमिंग टू क्लास. समझा? राइट? उसके लिए हैंड राइटिंग क्लासेस होता है अलग से. हाँ, you have to look here because this is important to understand. There is a particle moving in a what line? Come on, straight line. Is there an angular motion associated with it? Yes. Why I tell you? Imagine you are looking at this body from this point A. Right? ये body जा रहा है सीधा. तुम कहां से देख रहे हो बोले? A से. So what you do is you join this A to that point. बराबर? That is your position vector R. What is it called as here? Position vector R. Now think up. Right? When the body goes here, will the position vector change? Yes or no? Has the position vector swept out an angle? That's why even this is contributing to a what? Come on, angular motion. Has everybody got this over here? Right? So why is it contributing to an angular motion? Because there is a change in what? Come on, angle. Are you all getting this over here? Imagine you're looking at this body from here, B. Right? Somebody else comes and that person is looking at this body from this point over here. ये कौन सा point है बोलो? B. उसके लिए position vector ये होगा. अरे बोलो आया ना? तो जब वो बॉडी इधर जाएगा, will it sweep a different angle? Yes or no? तो इसके हिसाब से आंसर अलग आएगा. नहीं समझा? So if the particle is moving in a what line? Come on, straight line. But will there be different angular motions over here? That is why a particle moving a straight line will still have a what? Come on, angular momentum. समझा क्या तुमको over here? Sure. It's like this. एक झाड़ है समझो, and you're traveling in a bus, right? You are the driver of the bus, let's say. So you look at the tree. After some time your bus will come here because the bus is moving. Has the angle changed? Yes or no? So there is a what term involved? Come on, angular momentum involved. And what is the formula for the angular momentum? Tell me. MVR sin theta. Now if I want the theta, what I'll do is, right? So I'm just telling you this for explanation, right? or let me keep this, let me draw another diagram, right? So I have a particle, right, mass m, okay, moving with a velocity v, right, along this line. Okay, one of you is looking at this body from this point, which is point, what, tell me here, A. I'll join A to that particle. This is my position vector R. बोलो क्या बोलेगा उसको? Vector R. I want the angle between R and V. Come on, tell me, is this the angle? Why not? Head to tail. What do we do now? Tail to tail. तो क्या करने का बोला? Extend. तो मैंने extend किया इसको भैया, right? This is by which vector? Tell me R vector. Tell me, is this the angle between the two? Sure. उसको मैं क्या लिखा बोला? Theta. So what is the angular momentum? Momentum of the body about point A. तो LA, right? Formula क्या है उसका? जल्दी बोलो. So m into v into क्या आएगा बोलो? R into क्या आ जाएगा बोलो? Sin theta. Has everybody got this? Right? But now there is somebody else standing here, right? B पे, B के हिसाब से देखते हैं. तो B के लिए पोजीशन वेक्टर तो ये आएगा. Is this vector and this vector the same or different? Different. तो मैं इसको क्या बोलता हूँ? इसको यार R dash. बोलो क्या बोलेगा उसको यार? R dash. I want the angle between R dash and V. बोलो, what should I do? Extend what? Come on. Whom? R dash. Okay. So ये theta था भैया. I'll extend whom? Tell me भैया. R dash. So this is whom? Tell me भैया. R dash. And students, this is the angle between the two. Let me call the angle as what? Tell me भैया. Alpha. All of you now tell me, what is the angular momentum of the particle about B equal to? Come on. LB का formula. Start. M into क्या है बोलो? V. अच्छा, V और M सेम है क्या अलग अलग है? सेम. अच्छा, into क्या है बोलो? R dash into sin alpha. Has everybody got this? अच्छा, ये देख के थर्ड पर्सन आता है C, right? अब C खड़ा है यहाँ पे, right? You tell me, how should I get angular momentum for C? Tell me first. Join what to what? Come on. C to the point. ये बराबर everybody होगा, right? तो ये क्या आएगा बोले? अच्छा, is it the same vector? Something else. Something else. क्या लिखेगा मैं इसको? R double dash. Okay, I want the angle. क्या करूँ? Extend. तो R double dash को extend किया मैंने. हाँ, ये क्या आएगा मेरा बोला? R double dash. ये angle same है क्या अलग होगा? अलग. उसको क्या लिखेंगे मैं बोला? Beta. All of you together tell me, what should I write for angular momentum, right, about point C? Come on, start. LC. Start. MV R double dash sin beta. Are all of them talking about the same particle? But are all of them getting different angles? Yes or no? अच्छा, ये देख के एक्साइटमेंट में D आखिर इधर खड़ा हो गया. अरे मूड उसका है ना, तो मैं उसको ज्वाइन करता हूं. Can you tell me what is LD? Very good. क्यों? And the parallel vectors, angle क्या हो जाएगा? Zero. Angular momentum क्या हो जाएगा? And that's right ना? See, when the person is here, तो ये पहला ज्वाइन करो, दूसरा ज्वाइन करो, angle क्या हो गया? Nothing. तो angular momentum भी क्या हो गया भैया? Zero. Are you all getting it over here? अच्छा, इसमें direction भी चाहिए. Angular momentum vector है कि scalar है? Vector. So look at the blue one. Can you all see the blue one? R to V. R to V. Clockwise, anti-clockwise. Come on, all of you. हाँ, क्या आएगा? Clockwise. ये clockwise मतलब क्या है? Negative. Has everybody got this over? Look at red vector. R dash to V. Clockwise, anti-clockwise. Clockwise. तो ये भी कैसा आ गया होगा? Negative. अच्छा, look at the green vector. R double dash to V. Anti-clockwise. Anti-clockwise क्या आएगा होगा? Positive. Has everybody got this? This is your angular momentum vectors. Clear about that over here? Anyone with any doubts regarding this? Okay. But this can be done in a better way. I'll show you how. What I do is, I talk about this R. I'm looking at A का motion over here. So A, blue diagram. All of you look here. This is your R vector. You have the particle here, M, moving with a velocity, what, tell me here? V, right? And this, when I extend R, this angle was what? Come on, theta. If I extend the line of motion, come on, what am I doing? Tell me first. Extend extending the what? Come on, line of motion. मैं लिखते भी देता हूँ. So I'm extending the what? Tell me here. Line of motion. Clear? Tell me how much is this angle? Very good. Reason? Vertically opposite. Corresponding नहीं बोलते. क्या बोलते उसको? Vertically opposite. Now what I do is I drop a perpendicular to the line of action. Right? So extend the line of motion and what? Tell me over here. Drop. Whatever I'm doing, I'm writing up. Whatever I do, tell me here. Drop a perpendicular to the line of motion. LOM का फुल फॉर्म क्या बोलेगा? ये लॉज ऑफ मोशन नहीं है. बोलो क्या बोलेगा? लाइन ऑफ मोशन. तो बोले सर आपने पहले तो लॉज ऑफ मोशन बोला. हाँ अब कौन है बोलो मुझे? लाइन ऑफ मोशन. So we have done that over here. Can you see a right angle triangle? Come on. Yes or no? Right? If I call this as x or y, चलो y axis है. Right? In this right angle triangle, right? What is sine of theta equal to? Opposite upon hypotenuse. बोलो कौन है opposite side? Y. Upon क्या आएगा R. So students, what is y equal to? R sine theta. Sure, can you see R sine theta? Yes or no? So this term can be written as what? Come on. Y. Is this y called as the perpendicular distance? जल्दी बोलो. Yes or no? The angular momentum about A can be written also as what? Come on. MV R perpendicular. What is R perpendicular? Perpendicular distance from the line of motion. बोलो क्या बोलेगा उसको? This is the formula for what? Tell me your angular momentum about A. बोलो क्या बोलेगा उसको? Formula for what? Come on. Angular momentum about A. So all of you tell me what is LB का formula written as? Come on, start. MV R dash perpendicular. What is LC का formula? Start. MV double dash what is D का formula? 0. क्यों? It's on the line of action. Perpendicular distance क्या हो जाएगा? 0. So you have to remember this over here. How do you get perpendicular distance? All of you, fast. Extend the line of motion. So to find angular momentum. But what are we doing? Tell me here. To find angular momentum, what do we do? Come on, fast. 1. Extend the line of motion and drop a perpendicular. Okay, are you all getting this over here? So let's do a sum on this. So let us say I have a question 1 in which we have a particle of mass 2 kgs. Okay, right, moving in a straight line with a velocity of 10 meters per second. Right, pay attention, don't write. I have the y-axis. I also have the which axis? Tell me here. X-axis. Right, this point happens to be the what? Tell me here. Origin. Keep the pen down. Right, and this intercept here is 5. Come on, what is the intercept? Tell me here. 5. That's given to us. The question is, what is the angular momentum about the origin? What do I want to find out? Tell me. Angular momentum about the origin. Read this out. How do I find out angular momentum? 1. Extend the line of motion and what? Come on. Drop a perpendicular. Sure about that? So I've got this over here. I'll extend the line of motion. So what is in black is the question. Now I'm doing in blue is the solution. So I'm extending the line of motion. So what do I do next? From there. Origin. Where do you want? So you drop a perpendicular. Is this angle 90? How much is this distance? 5 meters. बोलो क्या बोलेगा उसको यार? 5 meters. Who is 5 meters? Tell me यार. R perpendicular. What is the formula for angular momentum about O? Come on, all of you start. M V R perpendicular. So M का value fast 2. V का value 10. R perpendicular 5. Hey, what's the answer? 100 unit लिखते. M का unit kg. स्पीड का यूनिट मीटर पर सेकेंड. आर का यूनिट मीटर. तो क्या बचेगा भैया? 100 kg मीटर स्क्वायर पर सेकेंड. Has everybody got this over here? Sure, right? Next question, same thing. Angular momentum about 0, 3. I want to find out what? Come on. Angular momentum about which point? Come on. And this is point P. Right? So ये origin है 0, 3. Where is 0, 3? Come on. On the which axis? Come on. Y. So y axis पे I go here. कितना distance value बोला है? 3. Sure? Right? So this is now your point P along which you want to. So I want to find out LP now. Clear? Formula क्या लिखेगा मैं बोला है? MV R dash perpendicular. बोलो क्या करेगा? R dash perpendicular. Come on, what is the step to do it? One. Extend, already extended हुआ है. बोलो आप क्या करो? बोलो. Drop a perpendicular. So let me drop a perpendicular from P to that point. Is this angle 90? So I want this distance. ये मेरा R perpendicular है. ये कितना है? बोलो. 3. ये कितना आएगा? 2. Sure about that? मेरा आंसर बोलो. Start. All of you. LP is equal to start क्या? M 2 V 10 into 2. Is sure about that? The answer 40 unit kg meter square per second. Has everybody understood this over here? अच्छा direction चाहिए मुझे. तो look at this V and look at this R. R cross V. So R is here. ऊपर जाएगा ना? And V. Is it clockwise or anti-clockwise? तो ये कैसा आएगा बोलो? क्लॉकवाइज मतलब क्या आएगा बोलो? नेगेटिव. ये भी क्लॉकवाइज आएगा तो क्या आएगा भैया? नेगेटिव. हैज एवरीबॉडी अंडरस्टूड दैट भैया? एनीवन विद एनी डाउट्स रिगार्डिंग दिस? चलो लेट मी डू अ थर्ड पॉइंट. एंगुलर मोमेंटम अबाउट 4,2. First identify 4,2. Come on, where is 4,2? I have got a green pen. Tell me where is 4,2? Stand up and say. 4 on the axis. 1 2 3 4. ये 4. Okay, good. 2 on the y-axis. So the point is here. ये बराबर हो गया? So let me say this point is Q. बैठ जा. Point Q. ये third sum है students. ध्यान दो जरा सब लोग. So this point is this, right? ये distance कितना है students? 2. बराबर? ये distance कितना है बोला? 4. Right? I want to get the angular momentum about that point. So I'm going to write LQ. ये formula क्या आएगा भैया? MV R double dash perpendicular. How do I get R double dash? Read. 1. Extend the line of motion which is already done. 2. Drop a perpendicular from where to where? Come on. 2 to that point. Shall I draw this? Is this 90? मतलब ये distance आपका क्या आएगा बोलो? R. How much is this? 2. How much is this? 5. So how much is this? 3. Are you all getting it? Answer. बोलो start. LQ. ये बोलो क्या आएगा? 2 into 10 into 3. Answer 60 kg meter square per second. Has everybody understood this over here? ऐसा मैंने आपका अलग अलग क्वेश्चन दिया. Will you be able to do it? This is your angular momentum term. What is the trick? Actual formula मैंने आपको बताया. The trick is to get a what? Come on. Perpendicular distance. How do you find out perpendicular distance? 1. Extend the line of motion. 2. Drop a perpendicular. If you remember torque का sum, I told you 3 ways to do it. What are the 3 ways? Come on. 1 was RF sin theta. What is the next one? Come on. Resolve R perpendicular, right? Or resolve what? Tell me F perpendicular. Do you remember that? Same thing we have done here, but this time this is a little more easy, so we have done that. Has everybody got this? Achha, you didn't tell me the direction. So draw this vector from here to here. This is R. You have to extend it R. This is R double dash vector. This is V. Clockwise or anti-clockwise? Clockwise. मतलब क्या आएगा भैया? Negative. Is this clearly understood by everybody over here? Same particle का बात किया, but 3 अलग अलग लोगों ने 3 अलग अलग क्या दिया बोलो? आंसर. आपको ऐसा कि किसी ने पूछा क्यों, क्या आपका आंसर रहेगा? रेडियस लगता. मीनिंग क्या इसका? डिफरेंट एंगल्स सबटेंड करेगा, राइट? सो सपोज अ बॉडी इज मूविंग फ्रॉम ए टू बी. नाउ व्हेन यू आर लुकिंग फ्रॉम हियर, योर एंगल इज समथिंग. If you happen to look from here, will your angle be the same or different? Different. If you happen to look from here, is the angle different over here? So why is angular momentum different? Angle subtends are what? Come on, different. So the angular momentum also will be what in here? Different. Has everybody understood this over here? So you have to remember this, a very very important term, right? Angular momentum. Has every student understood this? Tell me fast. Yes or no? Sure. So I have told you this over here. जिसका ये बाकी है पहला ये लिखेगा. Then this is 1, right? Okay, ये सब मत लिखो तुम लोग, right? Have you all understood? here उसका meaning है. Why has a, suppose somebody comes and asks you that if a particle is moving in a straight line, why does it have an angular momentum? What would your answer be? It subtends what? Come on. Angle depending upon the observer. It depends on what? Come on. Angle depending on the अलग अलग observer का अलग अलग angle है कि same angle है? अलग. So I've shown you this. ये last में करने का, पहला ये करने का, फिर ये लिखने का A B C D. मैंने 4 अलग कलर्स लिखा है. I hope you are understanding those colors, right? And last way is this part for you to understand. Is that clear to every student? Once you have done that, then you will copy down those sums. Those are three sums, right? Yeah. Acha, mark also you want me to do. So this is 1. Then this is 2. Now don't do this इसके बाद ऐसा you don't know डायग्राम के बाद ये आएगा. Want me to do 3 and 4? क्या बोलते हैं बेशरम. सरकाजम समझता नहीं क्या तेरे को थोड़ा सा. 3, राइट. हाँ ये सब इरेज होने वाले हैं. हाँ and this is 4. Is that clear to everybody? Huh? Come on, do it fast, quietly. No talking to me also. Raise your hand if you want. Yeah, you what say? You raise your hand now. Please say something. Something. कुछ तो बोलना पड़ेगा कुछ तो. कुछ तो बोलेंगे. हाँ बोल दे कुछ तो. You can tell your marks also loudly. हाँ बोल.
So we can use the formula LPR sin theta.
Yes. हाँ बोल. So I saw R, na? This was R when I took this particle here. This was R, and this is V. It's R cross V or V cross R. So go from R to V. क्या ये? Clockwise. समझा? चलो. जरा पॉज कर देगा. Now, how will you do this sum? Is there anybody who got some answer? What's your answer? 16 root 2. 16 root 2. 16 root 2. 16 root 2. Okay, chalo. So, right or wrong मुझे मालूम है हम लोग चेक करते हुए because I've just made the sum now. Now, everybody pay attention including Samaira. Especially बोलना पड़ेगा ना, right? So Samaira, can we pay? Look here. Come on. So looking at this, stand up. Let me ask you the questions. Looking at this, stand up. खड़ी तो डर मत ऐसा. हाँ, simple question है. Looking at this, y is equal to mx plus 2, right? Right? Where m is just this over here. Right? In fact, I should not have told you this. ये 1 होना चाहिए था. हाँ m आता है ना तुम लोग के इक्वेशन में. हाँ चलो तो 16 रूट 2 कैसा मिला फिर? It will matter. There's some angle. चलो. So I'll just modify the question. It's y equal to x plus c. ये देख के what comes to your mind? कौन सा फॉर्मूला याद आता है? y equal to x plus 2 देख के. y is equal to mx. Very good. चलो सिर्फ फिर आता है तुमको. So y equal to mx plus c. Come on. Does everybody think about this? Right? If you stop writing, you can think. चलो good. Hey, look at this. Compare. Stop writing. What is the value of c? 2. Student, c happens to be the y-intercept. बराबर ना? And what is m? 1. And m is nothing else but tan theta. Now tan theta मतलब theta is equal to 45 degrees, and that's how it will matter. Right? Look here. Look here now. Now don't write. Okay. Let me draw this on a graph. So I have my y-axis. Right? I also have my what? Tell me your x-axis. And let me draw. The particle is moving along this line. So what I'll do is I take the particle, right, at some point at an intercept of y equal to what? Come on, 2. So y2 ये है समझो. And it is at an angle of how much? Come on, 45. तुमको समझ में आ रहा है क्या? हाँ हाँ थोड़ा ध्यान दो. So I'll draw this horizontal and I'll measure an angle of what? Come on, 45. Is that clear? Now in that sum which I showed you, the particle किधर भी हो सकता है, really doesn't matter. So the particle is somewhere here or here or here, wherever you want to do it. but it is moving with a speed of how much? Come on. 4 √2 meters per second. Is that clear? Right? And I want to measure this from the what? Come on. Origin. From the what? Tell me, origin. तो क्यों ऐसा मेरे को तो क्या ये कर रही है क्या? हाँ सर सर मतलब यू आर ट्राइंग टू टेस्ट मी. हाँ ओके डोंट. हाँ आराम से करो एवरीबडी, नहीं तो मैं ऐसा बिठाएगा तुमको अभी. हाँ गुड चलो. सो दिस पार्टिकल इज यहाँ right and you have this. I want the perpendicular distance from what? Come on, origin. चलो समय tell me how did you get origin से वो distance? You remember मैं लिख के दिया था इधर ऐसा कुछ तो क्या था? तेरा क्या लैंग्वेज है रे? ओ उसके बाद में नहीं बोलने का कुछ. हाँ ओ स्टॉप बोलो क्या करने का? एक्सटेंड का कुछ तो लिखा है यार. तेरा अच्छे हैंडराइटिंग में रहेगा किधर तो. Very good. Extend the what thing here? Line of motion. So students, I'm going to look here. I'm going to extend this line of motion. समझा गया? You can extend it that side also, right? Till you go to the edge of the board. Wherever you want, you can do that. Right? चलो आगे बोलो क्या करने का next? Drop a perpendicular from the origin to this line. Are you all getting it? This is what I want. ये है परपेंडिकुलर डिस्टेंस बराबर ना. अभी तो हमने सिंपल सम किया, अब थोड़ा और ट्रिकी हो गया. ये 2 है स्टूडेंट्स, तो ये जो इंटरसेप्ट क्या आएगा बोलो 2. राइट. अच्छा ये अगर मैंने एक्सटेंड किया लाइन, ये 45 है, ये एंगल क्या आएगा 45, तो ये एंगल भी क्या आएगा बोलो 45 डिग्रीज. इफ आई वांट द डिस्टेंस आई विल यूज sin 45 इन दिस ट्रायंगल. sin 45 is equal to opposite. Who's the opposite? R perpendicular upon क्या आएगा 2. So what is sin 45 का value? Come on, 1 upon √2 is equal to what? Come on, R perpendicular upon 2. So R perpendicular will be equal to what? Come on, 2 upon √2. Now you can solve it. You don't want to solve it. That's your choice. I know the formula. Formula is MVR perpendicular. M. How much is M? 2. How much is V? 4 √2 into this is what? Come on, 2 upon √2. A √2 क्या है बोलो cancel. 4 2s are 8, 8 2s are. Angular momentum is 16 kg meter square per second. Did you all understand this over here? Right now this is a JEE question. Simple questions are some. This is not difficult, but everybody should remember y equal to x plus 2 में क्या याद आ गया? mx plus c. Draw that and get the answer. Has everybody understood how to go about in this sum? Right? So you should stop writing when I'm telling you. You should first trust your instinct. The moment you think something, you have to write it down. Sometimes this is a practice session going on. Just so no, they're not an exam. Exam ऐसा समय है तुमको नहीं आता छोड़ देने का. Right? But if it is a similar sum like this, now you know how to do it. I all getting it. What did I do? I first, the moment this came to this, what came to my mind? I'm not mine, even your mind, that same thing came. Yes or no? I saw it, I wrote whatever data is. The moment I know the data, what did I do? Tell me, I said we'll what? Come on, plot a graph. We plotted a graph, then we realized we need to what? Come on, find out the what distance? Perpendicular distance. For that she told us the method. What is that? Samaya, tell me. Extend the line of motion and then what? Come on, tell me. Drop a perpendicular. What is the step? Tell me fast, fast. Extend the line of motion and drop a perpendicular. Is that clear to everybody over here? Come on, do it fast. Yeah. Hey. We know force is defined as rate of change of linear momentum, right? We can write change in momentum as final momentum minus initial momentum. I've done this with you, right? Collisions. So we can write dp is equal to f dt. This f dt is called as linear impulse. So we write p final minus p initial. Please pay attention, is f dt, right? So we come to the impulse momentum theorem where p final is equal to p initial plus f dt. And this we named it as the linear impulse momentum theorem. Now I want you to समझा तुमको linear impulse what tell me momentum theorem. एक मिनट जरा बैग दो इधर, एक मिनट बैग दो इधर, बैग दो इधर। मैं बैंक बुक निकाल के हर बेंच पे एक एक बुक रखने वाला है। दे बैग, दे बैग, दे जल्दी बैग दे, बैग दे, इधर बैग पास कर दो। ना आई एम आउट ऑफ द सीन ना। हाँ चलो that was a good one. Yeah, he's taking his job seriously. ऐसा है. So what we need to do now is, right, we need to take our books out and keep it on different benches. After that we'll look at rotational motion. चलो stand up. Maybe you know everything, that's why. बोल क्या लिखूं मैं? देखिए ब्लैक में लिखा भी, ब्लू में क्या लिखूं? वो क्वेश्चन है ना. चलो we'll write torque. Torque is equal to what? Come on. Rate of change of what? Come on. Angular momentum. Well, what is torque defined as? Rate of change of? What do I write next here? Come on. I can write dl as tau dt. बराबर everybody? What do I write next? dl को कैसा लिखेगा बोलो? dp को tf minus pi लिखा, तो dl को कैसा लिखो बोलो? lf minus li is equal to, बोलो क्या आएगा भैया? tau dt. Let us take li on the other side. So L final is equal to, बोलो क्या आएगा? L initial plus tau dt. Students, this is called as the angular impulse momentum theorem. बोलो क्या बोलेगा उसको यार? Angular impulse momentum theorem. Right? So F dt is called as linear impulse and tau dt is called as what? Come on, angular impulse. What is impulse? Force acting for a short interval of time. बोलो क्या बोलेगा उसको? Now here what we did is, when we did law of conservation, we did the external force acting on a body is 0, and then we got P final is equal to what? Come on, P initial, and we named it LOCO-LM. Do you remember the full form of this? Come on. Law of conservation of linear moment. Please tell me what should I write here. Come on, start. No, but what should I write? If tau is 0, then what will happen? Come on. LF is equal to Li, and what is that called as? Come on. Law of conservation of. Are you all getting it, everybody? Next lecture we'll do more about this over here, right? So very, very important term here. So today we have learned two things. Come on, what and what in here? Radius of gyration and angular momentum. Angular momentum, radius of, stop writing. What does angular momentum tell you about? Distribution, sorry, what is radius of gyration tell you here? Distribution of mass from the axis of rotation. Angular momentum over here is for, it's a vector quantity over here because it sweeps out different angles over here. We have this term. Is this clear to everybody over here? Right, have you all understood this over here? So when to use the formula mvr sin theta and when to use the formula I omega? I omega for a rigid body. So if I talk about a fan, what should I use? But if I talk about a stone being thrown, mvr sin. So in projectile motion, what should I use? Reason? It's a point mass move करेगा तो क्या आ जाएगा भैया, right? But if I take the spin and I turn it, what will happen? Come on, I omega. Has everybody got this over here? तो तुमको ये समझना, लास्ट में ये है, इसके ऊपर हम लोग और करेंगे in the next lecture. Is that clear to everybody over here? Right? चलो copy down this.